graphs and their properties. So last chapter, we did a lot of factoring. So we've already worked with quadratics quite a bit. Now today, we are going to focus on their graphs and the properties that go with them. So a quadratic graph is called a parabola. So a parabola is a U-shaped curve that is the graph of a quadratic function. Okay? The standard form for a quadratic function is y equals ax squared plus bx plus c. And this is something that you guys should already be quite familiar with. So the first property of a quadratic graph that we're going to look at is the shape of the parabola. So the shape has many factors that will affect it, but the main one of those being the leading coefficient, or the a value. So if the a value is greater than 0, then that tells us that our parabola is going to open up. If our a value is less than 0, that tells us that our parabola is going to open down. Okay? Our a value also indicates whether it is narrower or wider than the parent function. So if the absolute value of a is greater than 1, then that means that our graph is going to be narrower than our parent function. And if the absolute value of a is less than 1, that means that our graph is going to be wider than our parent function. So pretty much what this is saying is if the value is greater than 1, it will be narrower. If the value is less than 1, which would be a fraction or a decimal, it would be wider. Same with the opens up, opens down. If the value is positive, it'll open up. If the value is negative, it will open down. So the next property that we can identify is the axis of symmetry. Axis of symmetry. So the axis of symmetry is a line that isn't truly graphed, but we can graph it at the start, that indicates where the parabola is symmetrical. So we can calculate this line by calculating x equals negative b over 2a, which we can take the b and a value from our quadratic equation, or the equation of our quadratic. The last property we're going to look at is the vertex. So the vertex, we can determine maximum or minimum from our a value. So we have a maximum, our vertex is our maximum if a is greater than 0. And our vertex is our minimum if a is less than 0. It all depends on what direction our parabola opens. Also, we can use the axis of symmetry to calculate our vertex. So the x value of our vertex is going to be the same as the x value that we calculate for our axis of symmetry. But we would have to substitute this x value into our equation to find the y value. So that is the third of our properties. Okay, so next, looking at how we'll apply these properties on page number 2. So on page number 2, we are going to graph a couple of quadratics. So graphing a quadratic is just like a lot of the other graphs that we've done this year, where we will start by creating a table. But from the information that we learned in the last page, there's a couple of things that we can identify right away. So the first thing is a is less than 0. So I know that this quadratic, that's our a value there, is going to open down. From my info, I also know that the absolute value of a is going to be greater than 1. It's not a decimal. So I know that this is going to be a narrower graph. Okay. If I wanted to, I could calculate the axis of symmetry and the vertex maximum and minimum. But calculating my axis of symmetry, I have x equals negative b, which there is no negative b. So that'll just be 0 over 2 times a, which is negative 3. That gives me 0 over negative 6, which is just 0. So my axis of symmetry is going to be right at x equals 0, which is just my y-axis. So I could graph this in if I wanted to, but it is not entirely necessary. Okay, so now let's create our table and get on with the graphing process. So for our table, we need to select some x values and some y values. For your x values, you can select whatever ones you like. I'm going to go from negative 2 to positive 2. So for this process, you may want to use a calculator. But when you substitute these in, I'm substituting, I'll just do this first one, negative 3 times negative 2 squared, which equals y. Negative 2 squared is 4, so negative 3 times positive 4, which is just going to give me negative 12. And now we can just repeat the process. Negative 1 squared is 1 times negative 3 is negative 3. 0 is going to give me 0, negative 3, and negative 12. So please take your time when making this table. I know that I went through this fairly quickly. So now graphing these at negative 2. I know I don't have a good graph here. I'm going to be at negative 12, which here we'll just go by threes. 3, 6, 9, 12. 3, 6, 9, 12. So I've got negative 2, negative 12. Negative 1, negative 3. 0, 0. 1, negative 3. And 2, negative 12. And this is going to give me a quadratic function that looks something like this. Okay, and as you can tell, this is a parabola because it is U-shaped. Okay, sometimes we will have a C value. So for this one, I'm going to start by graphing my quadratic and then as a parent function, and then I'm also going to graph my quadratic with a C value. For this one, I'm not going to identify properties first. I'm just going to create my table. So I'll make that one as a blue line. I'll make that one as a purple line. So for my parent function, I'm going to create a table of x and y values. So for my x values, I'll use the same ones. Okay, now I'm going to substitute those values in. So negative 2 squared is 4, 1 squared is 1, 0 squared is 0, 1, and 4. And now for my other line, I'm going to use the same x values so we can see the difference when graphing with a c value. Negative 2, negative 1, 0, 1, and 2. Now I'm going to repeat the process. So negative 2 squared, we know that is 4, minus 3 is 1, 1 minus 3 is negative 2, negative 3, negative 2, and 1. So now I'm going to create my graph. So I'm going to need negative 1, negative 2, negative 1, negative 2, 3, 4, 1, 2, 3, 4. And that should give me enough points to work with. So I have negative 2, negative 4, sorry, positive 4, which would be up here. Negative 1 and 1, 0, 0, 1 and 1, 2 and 4. And that is going to give me my parent function, which looks something like this. Obviously, I just have a rough sketch here. And for this one, I've got negative 2 and 1, negative 1, negative 2, 0, negative 3, so on and so forth. And as you can tell, this one will have the same exact shape as my parent function. It is just moved down 3 spaces, which is all from my C value. Okay, so I think we're going to call this one there. We will save this application problem for class. Please write it down now. That'll save us a lot of time when we get to class. I also have a couple more graphs on the second page that we will be sure to go over together in class. All right, thanks for watching.